Hello, Luke. Welcome to Lesson 88. Today we're going to be looking at quadratic equations and solution of quadratic equations by factoring. All right. Really the story is going to be all about the quadratic equations today. All right, and what they are and how we solve them. So let's just back up just a little bit. So up to this point, we've been solving all kinds of equations, right? But they've all been having kind of this form. We might have, 3x plus 4 is equal to 27. X minus 4 is equal to 2. 3x is equal to 2x plus 5. Something like this, right? All of these equations, they're all in what we would call the first degree. The first degree. All right, so look at the variables in this equation. In particular, we're looking at the variable x in these equations. And for all of them, the x, the highest degree that we have for x in any of these equations is just 1, right? In this first equation, there's only one x, and it has a degree of 1. That's the highest power. All right. The second equation, again, there's only one x, and it has the degree of 1. The third equation, we have two x's, but both of them have the degree of 1. So the highest power for that x is 1. So all of these would be considered first degree equations. Okay? First degree equations. But today, we are going to be taking a leap into kind of the next category of equations, and that is the quadratic equations. Whenever you see that word quadratic, you should think squared. All right? So instead of having x to the first power, we're going to look at equations that have x to the second power. So we might see something that looks like this: x squared plus 3x minus 4 equals 0. Something like this. Okay? This would be considered a quadratic equation. And again, don't get thrown off by that word quadratic. All that means is that the highest power of the variable is 2. And that's what we have here. Okay? So quadratic means squared. Quadratic means squared. That should be clear in your head. Okay? So the question becomes, how would we solve something like this? So if we have an equation that looks like this, where would we go with this? I mean, in the past equations, we've always said, well, let's get all of our x's onto one side. So let's move this 2x over to the other side, combine it so that we just have our x's, or x all by itself, and then we can eventually get down to x is equal to something, okay? But in this case, how would we do that? We put all of our x's on one side, great, but we can't combine these x's. We have an x squared and we have an x. We can't combine the two. So how would you solve for them? That's where things get a little tricky. And that's really what we're going to be looking at today. Before we do that, however, there's a couple of things that I want to go over to make sure that you understand in regard to quadratic equations. All right. And the first thing is that quadratic equations, we have a general form for them. All right. Remember we had a general form for functions or, functions. We had the y equals mx plus b for the line, right? That's the general form for the line, the equation of the line. Same thing applies here. We have a general form for quadratic equations, and it looks like this. All right. So we have some x squared term with some coefficient, whatever that might be, we call it a, plus another x term with, again, some other coefficient, we just don't know what it is, plus some term that doesn't even have an x in it, and then that's all equal to 0. This is the standard form for a quadratic equation. All right, so write this down in your notebook, memorize it. This is the standard form for the quadratic equation. And it should be pretty simple to memorize. We just have the squared term, and then the first powered term, and then no variable term, and then it's equal to 0. Okay? All right, the second thing that we want to talk about, or just make sure that you understand, and we'll be talking about this more in later classes, but just so that you can remember that you've heard it before, when we have equations where the variable is being raised to a power, The power, interestingly enough, the power dictates how many solutions or roots there are to this particular equation. Okay, so for example, in our, with some of our old equations, we might have had 3x plus 2 is equal to 6. Now, this x is to the first power. So that means that there is one solution. Okay, it's kind of interesting. There's one solution to this equation. Okay, there's only one x by which this 3 times that x plus 2 is going to give me 6. All right. Now, if I have a quadratic equation, well, then we have the highest power of the variable is 2. So that would mean that we have, and I'm going to be careful here, I'm going to say we have at most 2 solutions. Okay, 2 solutions. So that would mean that x could be one thing, and then x could also be some other thing. And both of those things would make this equation true if we were to plug them in for x. Okay? That's what that means. Now, I say at most 2 solutions for a couple reasons. First of all, many times there will only be one solution for you right now. Okay? So if I have a quadratic equation, you might say there's 2 solutions. But right now, you may only be able to find one of them. In fact, there may be some quadratic equations that you can't find either of the solutions to them right now. Okay, it's just we haven't learned enough yet. We don't have all of our tools in our toolbox yet to find both solutions to these quadratic equations. And then there are other equations where you could argue that there's only one solution to it. Other times people call it kind of a double solution, where x is kind of the same thing, only twice. So it's really only one solution. It's just doubled. But that would be another argument. So sometimes it appears that there is only one solution. So that's why I say at most. All right. So for right now, just know that there's at least one solution, but many times there are 2. Okay. And we'll talk more about that later. All right. And actually, this would apply for other equations as well. So if I have, x to the third is equal to some number, 24, and I tried to solve this, I could argue that there could be as many as 3 possible solutions. So some of these equations that are to the third power could have as many as 3 solutions. If you have an equation to the 4th power, well, then you could have as many as 4 solutions. And then to the 5th power, 5 solutions, and so on and so forth. So in general, that highest power of the variable dictates how many possible solutions you could have to the equation. All right? We just never have really cared for that up to this point because it's always just been one solution because we've only been dealing with x's to the 1st power. Okay? All right. So let's continue on. So that's kind of the general intro into quadratic equations. Now let's talk about what we would need to do to solve them. And the first step in solving them is learning a theorem. All right, so a theorem in math is like a rule. It's a hardcore rule that we can memorize and apply it to any situation. All right, so we have the zero-factor theorem, it's called. All right, the zero-factor theorem. So in your notebook, write this down, the zero-factor theorem. What is it? Well, it's very straightforward, but it's very powerful too. So all the zero-factor theorem is the observation that if I have, let's say I have a P and I'm multiplying it by a Q, and I tell you that this product will equal 0. All right. Now, I don't know what P is and I don't know what Q is, but I can make a very powerful assumption here. And that is that in order for this to be true, either P is going to be equal to 0 or Q is going to be equal to 0 or both of them are going to be equal to 0. Okay? Because that's the only 3 possibilities that would allow us to get 0 as an answer. All right? If P and Q were not 0, Think about it. You would not be able to get them to be, get the product of them to be 0. All right? Any number times any other number is not 0 unless one of those numbers or both of those numbers is 0. Okay? Hopefully that makes sense. So maybe we'll just throw in some numbers. So I could say that P is equal to 0. And if P is equal to 0, well then P times Q is going to be equal to 0. That would be true. All right? The other option would be that, this is option 1. Option 2 might be that Q is 0. So that would mean P times Q, which is 0. And that would also give me 0. So this one is true, this one is true. The third option would be, well, P would have to be 0 and Q would have to be 0. And then once again, I could get 0 as a product. Okay? So those are the only 3 choices. One of them has to be 0, for sure. All right? There's no other way to get a product to equal 0. Okay? And you might ask, well, great. Well, how does this help me? Well, let's think about it for a second. If I have something that looks like this, if I have something that says x minus 3, x plus 2 is equal to 0. Okay? Well, think about what this is saying. This is saying I have a sum, whatever this sum is, and I'm multiplying it by another sum, whatever that is, and that is going to equal 0. So essentially, you might think of this as being, this first parenthesis, this first set of parentheses as being this P over here, and this second set of parentheses is your Q, the Q over here. We're multiplying them by each other. It's P times Q, right? It's just we have an expression in those parentheses, okay? So, but what that would indicate then would be that either this x minus 3, if I knew what x was, and I could plug that in, whatever this sum is, it would have to possibly be 0. Either this one has to be 0, this sum has to equal 0, or this sum has to be 0, right? Because I'm trying to get to a 0 when I multiply these two together. And that can only happen if one of them or both of them are equal to a 0. Does that make sense? All right, just think about that for a second. Make sure that makes sense to you. Okay, so one of these, if not both of them, have to be 0 in order for this product to be equal to 0. And knowing that, we could then say, okay, well, if x minus 3 could possibly be 0, what's a possible solution for x? Well, if x minus 3 were 0, let's just set it equal to 0, we could solve this, move the 3 over to the other side, and say, well, then x is a 3. So x is equal to 3 would be one possible solution for this equation that we have up here. I'm not saying that it is the solution, but it's one possible solution. Okay? Now, what's another possible solution? Well, the other possible solution would be that x plus 2 would have to be equal to 0. So if x plus 2 were equal to 0, well then x, if I move the negative 2 over to both sides, then x is going to have to be equal to a negative 2, right? So either this x has to be a 3, in which case this first term, this first sum would be a 0, or this x has to be a negative 2, in which case the second sum would equal 0. And that way, in both cases, we would get that equal to a 0 when we multiply. All right? So for this particular equation, I can say that there are two solutions. The solutions are x is equal to 3 or x is equal to a negative 2. Those are the two solutions. Okay? Because those two solutions will make this equation work. It'll make it true. All right, so hopefully you understand that. Now you might ask me, well, Jim, what does this have to do with quadratics? Because these are still in the first term, the first power, right? The first power, okay? And I might say, yes, that's true. However, think about this. This is a multiplication problem. If you were to multiply this out, would it really be a first power equation or an equation to the first degree? Because this is multiplication of expressions, we need to use FOIL here. And if we use FOIL, we go x times x is x squared. That's the First, the outside is a positive 2x, the inside is a negative 3x. Combine those, it's a negative 1x. And then the last is a negative 6 equals 0. So if I multiply this out, lo and behold, it actually is a second degree equation, right? It's kind of disguised up here. It doesn't really look like a second degree equation, but if you multiply it out, you recognize that, actually it is a second degree equation. Okay? And so what did we just do? Well, we just solved a second degree equation. Look at that. Without even realizing it. We solved a second degree equation. All right? So let's put all this together. This, by the way, this is what we would call solving a second degree equation by factoring. All right? By factoring. So let's try a couple. So here we have an equation. This one is very obvious. We already have the x being raised to the second power. So we know that it's an equation of the second degree. So how could we solve it? Well, one tool that we've learned today is solving by factoring. Solve by factoring. All right. Now this will not always work. I should probably say that. This solve by factoring method that we're using right now, it's not always going to be as easy as it is in these cases. However, this is a starting point. So things will become a little more complicated later on. But this is where we begin. All right. Solve by factoring. And how do we do it? The first step is to always get the equation into standard form. So what was the standard form for a quadratic equation? Remember, it was ax squared plus bx plus c equals 0. All right, that is the standard form. So we need to get this equation into that standard form to start with. So we look at our x squared term. That's the one we write first. Then we need our x term. Well, that's way over here. So we need to move that over to the other side. So we're going to subtract that negative 3x from both sides. And if we do that, we end up with our negative 3x over here because that can't be combined with anything. We still have this negative 18, so that has to stay over here. And then we have the 3x minus 3x is going to be 0. And lo and behold, that's our standard form, right? We have our x squared term, we have our x term, we have our no x term, and then we have it equal to 0. So bingo, there we go. We have it in our standardized form at this point. Now, the next step is for you to look at this closely and see if you can factor this quadratic expression. And that's why you've been doing so many of these. You've been factoring a lot of these lately, so it should be second nature to you at this point. But we're going to try to factor this, okay? And to do that, remember, we use our two sets of parentheses, all right? And we start breaking this down. So x squared would indicate that there's an x in the beginning of each set. And then we have to think of an 18. How could we factor an 18 out so that if we subtract the two numbers, they'll give us this 3? Well, 6 times 3 is 18, and that would suffice. So we know we're going to have a 6 and a 3. This minus sign indicates that the signs are going to be opposite, and that the negative sign is going to go with the larger number. So we have the negative here, the positive here. If you want, you can double check this in your head, do a quick FOIL, and we should end up with this quadratic expression up here. And we do. Okay? So this is equal to 0. Now, this is where we were on that last problem, right over here. Okay? We're now at that point where we have a product going on, and that product has to equal 0. So that means one or both of these factors need to be 0. So all we have to do at this point is just set up two equations. We have an x minus 6. That has to be equal to 0. That's this one right here. And we could also have an x plus 3 equal to 0. That's this one right here. That's our two possibilities, right? That's where we get our solutions from one of these or both of these being 0. So we set them equal to 0, and then we can go ahead and solve these to find out what x is. So if we move the the 6 over to the other side, we end up with x equals 6. Over here, we solve for x, and we end up with x is equal to a negative 3. So those are our two solutions right there. And if we wanted to, we could go back and just confirm that. So if we go back to maybe we'll go back to here, our standardized form. Let's plug in a 6 and see what happens. Maybe we'll use red. So if we plug in the 6, we have 6 squared minus 3 times 6 minus 18. That should equal 0. Is that true? 6 times 6 is 36. Minus 3 times 6 is going to be minus 18. Minus another 18 is equal to 0. These two negative 18s can combine to give us a negative 36. And we have 36 minus 36 equals 0, which clearly it does. Okay, so that one worked out. Let's try the x equals negative 3. So if we plug that in for an x, we have a negative 3 raised to the second power minus a 3 times a negative 3 minus an 18 equals 0. We multiply this out, or we simplify it. Negative 3 raised to the second power is going to be 9. Negative 3 times a negative 3 is going to be a positive 9. And then we have this minus 18 at the end. 9 plus 9 is 18. 18 minus 18 is 0. And 0 does equal 0. So you can see where both of these values, 6 and negative 3, for x, they both would give us true equations. And since we know this is a quadratic equation, which means that there are at most 2 solutions, we know that we found all of them. Those are the only 2 solutions that'll work for this equation, because there can only be 2, and we found 2. Okay? All right, so now let's just do some practice at this point. We're not going to learn anything new. It's just practicing. So go ahead and pause the video, try this one on your own, and then we'll do it together. All right, so the first step, as we said before, is to get this into standard form. So we have, let's move this negative 4x squared over to the other side. And when we do that, we're going to change the sign. So it's going to be a 4x squared minus a 25 equals a 0. Okay. All right. Now you might say, well, this isn't quite in standardized form. We don't have the middle term, the 0 term. And you'd be right. Yeah. If we really wanted to get this into standard form, we'd say this is 4x squared minus 0x or plus 0x minus 25 is equal to 0. Okay. You could go there and say, there's my strict standard form for this quadratic equation. All right. However, this 0x doesn't really do us anything, so we'll just leave it as the 4x squared minus 25 is equal to 0. Now, the thing to recognize here is again our factoring, and we need to think back to all of our factoring rules and methods that we've learned. And in here, we can recognize that this is the difference of a square, right? It's the difference of a perfect square. So we can use that rule to factor this. So using the difference of 2 squares, we know that we'd have a minus and a plus. This 4x squared, we'd kind of take the square root of that and get 2x on both of these. And then the 25 would break down into a 5 and a 5. Okay? Right? Recall how that works? This is going to be set equal to 0. Okay, now we're at this next step, the new step for today, which is taking these 2 factors, factor 1 here, and setting that equal to 0. And then taking the other factor, which is this factor here, and setting that one equal to 0 as well, to find out what x would be in both of these situations. All right, so we solve this one by moving the 5 over to the other side, and we get 2x is equal to 5. We divide both sides by 2, and we get x equals 5 halves. Right? And over here, we have 2x, move the 5 over to the other side, equals a negative 5. Divide both sides by 2, right? And we end up with x is equal to negative 5 halves. So here, they're just kind of opposite solutions. We have x equals 5 halves and x equals a negative 5 halves. Those would be the 2 solutions. And again, since this is a quadratic equation, the most solutions we can have is 2. And since we have 2, we know that these are the only 2 for this equation. Okay? All right, let's try another one. Give this one a try. pause the video and give it your best shot. All right, so here again, we try to get it into standard form. We're just going to move this negative x squared over to the other side, and to do that, the sign changes. So we have x squared plus x minus 56 is equal to 0. All right, and we can factor this. So we will have our two sets of parentheses. We have our x and our x. The signs are going to be opposite. And I think we're going to get a 7 and an 8 for the factors on the 56, so that they'll subtract to give us the 1. The positive goes with the larger number, so that would go with the 7. And we have an 8, and then we have the 7 over here. And if you want to do a quick FOIL check in your head, yep, that looks good. So that's going to be equal to 0. And now it's just as simple as looking at, what these two sets, these two factors, set them up so that each of them is equal to 0. So we have x minus 7 is equal to 0, and we have x plus 8 is equal to 0. And this means that x has to be 7 or x has to be a negative 8, right? So those are our two solutions. Okay, there we go. Let's try another one. Try this one. All right, so let's break it down. Try to get it into our standard form. In this case, we want to move the 9 over to the other side. And we have a 3x squared minus 6x minus a 9 is equal to a 0. There we go. There's our standardized form. Okay. Now we look at factoring. Now, don't make the mistake here and jump right into, well, we need to get our two parentheses going here. Okay. Don't jump into that right away. I guess maybe I should have been stating this earlier, but we want to make sure that the first thing we do is look for any, more basic factoring here. Is there anything that's shared in these three terms that we can pull out? And the answer is yes. We could pull out a 3, right? Every term has a factor of 3 in it. So let's get rid of that first. So we pull out a 3, and we're left with an x squared minus a 2x minus a 3, right? Does that make sense? Equal to 0. Now we can look at what's inside this set of parentheses and say, okay, is there anything else that we could do to factor this? And yes, now we can take that, and maybe I'll just keep this color. We're going to have 3, and then we're going to have kind of this, well, I'll even keep it like this maybe. We'll just keep this parenthesis here just to make things really clear. So we'll have this 3, this big parenthesis. This is all equal to 0. But inside this big parenthesis, we're actually breaking this expression down into two parentheses, two sets, right? So if we factor that, we have an x here, we have an x here. It's going to be a minus and a plus, and it's going to be a 2 and a 1. And the 2 is going to go, the larger one, 2 is going to go with the negative. So we have 2 here, 1 here. Wait a minute, something's not right here. I'm sorry, 3 and a 1. What am I doing? 3 and a 1, not a 2 and a 1. Confusing myself. So this should be a 3. 3 and a 1. There we go. That should work out. Negative 3x, positive 1, negative 2x, yeah, negative 3. Yep. Okay, so there you go. So there we have our factorization of this expression. And now what can we do? Well, notice that this 3 on the outside really doesn't do much for us, if anything. Because in order for this, and again, this is very critical here. This is something to be absolutely sure that you're aware of. Notice there is all multiplication here. We do have some sums, but those sums are being multiplied. So this 3 is being multiplied by this x minus 3. This x minus 3 is being multiplied by this x plus 1. You could, and there's no addition going on between these multiplications. So everything is being multiplied if you kind of package these parentheses together. So this 3 really doesn't mean anything in this case. In a sense, I could even just say, well, let's just divide out the 3 and divide that on both sides. And 3 divided by 3 is going to eliminate, And we're going to be left with what's inside here, which is just the x minus 3 times the x plus 1. And then over here, 0 divided by 3, well, that's just 0. Okay? And that's all right. So you kind of think of it that way. You would never want to then look at this and say, well, let's divide this by an x minus 3 and divide this by an x minus 3. That's a mistake some students make. Because then what happens would be, okay, sure, that's going to cross out. We're going to have an x plus 1, and then 0 divided by x minus 3 is 0, and then x has to be equal to a negative 1, right? Well, that is somewhat right, but the problem is that we've eliminated an x here by dividing it out, okay, by 0, or taking 0 and dividing it by the x. So it's all right to divide this 3 by the 0 because the 3 term doesn't have an x in it. But if there's an x in it, never divide, 0 by a term that has an x in it. What you're doing is you're losing a solution when you do that. So just a word of warning there. Sometimes students ask why that won't work, and you're just going to have to remember that it doesn't if it has an x in it. All right, so now I got to erase a bunch of stuff here. All right, so once again, we're left with this x minus 3x plus 1. Okay, and at this point, we see that now we have our factors that need to equate to 0. So therefore, x minus 3 has to be equal to 0, or x plus 1 has to be equal to 0, which would imply that x is a 3 or x is a negative 1. Okay, so those would be the two solutions for this equation. Okay, very good. And that's about as tricky as it's going to get right there. So I think we'll stop here. Work on your seat work with these. Just remember your factoring. That's probably the biggest part to this. And if you've got your factoring down well, then this shouldn't be a problem for you. It should be pretty straightforward. All right, so great. We will stop here, and I will see you tomorrow.